Welcome to this series on HC probability, a topic that many students find quite difficult. And I think the reason for this is because of the way that we're taught how to approach these questions. Often we're not given the proper background knowledge, things like vocabulary and notation, which are really important for us to be able to look at questions, break them down into simpler components and work through them in a methodical way. Instead, we're just given questions, we try to do them in our head, and then if we get it, we get it. If we don't, we don't, which is not which is not ideal. So in this series, we're going to learn how to break down these questions in a more methodical way. So the first thing we're going to go through is just some terminology. First up, an experiment. What is an experiment? It's basically just the entire situation in a question. And for all of these definitions, we're going to link it to a question, an actual question in a second, so that will give us more context. Sample space, this is all of the possibilities in an experiment. An outcome is a specific element in the sample space or a specific, an outcome of how the experiment will play out. An event is a subset of the sample space, but I think a better way to think of it is a collection of outcomes. And here I've just got kind of a fundamental way we can think of probability, which is the number of desired outcomes over the number of total outcomes. So let's come down to this question here. It says a bag contains 3 pink balls, 5 blue balls, 2 green balls, and 5 orange balls. And we pick one out at random. So what is the experiment in this case? It's simply just picking out a ball from the bag. What is the sample space? Well, what are the possibilities? We could get a pink ball, we could get a blue ball, a green ball, or an orange ball. So this collection right here is our sample space. And each of these individually are outcomes of our experiment. And an event is a collection, like I said, a collection of outcomes. So pink or blue, this could be an event. Now let's try jump into the question. After getting those definitions out of the way. Part A says, what is the probability that the single ball that we pick out is going to be green? So probability of green. Well, going back to that definition, number of desired outcomes over the number of total outcomes. So there are 2 green balls over 15 balls in total. So that's our probability. Part B, what is the probability that the one ball we pick out is going to be pink or orange? So I'm going to name our outcomes to make it a bit shorter. So P is going to stand for picking out a pink ball, and O is going to stand for picking out an orange ball. So I want the probability of pink or orange. This U looking symbol is our union symbol. It's the OR symbol, and I'll cover more on this in a second. So again, desired outcomes, there are three pink balls and 5 orange balls out of 15 balls in total. So the probability of pink or orange is simply 8 on 15. Okay, now we're going to be looking at different ways that events, collections of outcomes can arise. First is complements, not. This symbol here, this line above A, means not A. So this means what is the probability of A not occurring, which is always going to be 1 minus the probability of A occurring. Next is intersections, which is a fancy way of saying and. This here means the probability of A and B occurring. And unions, fancy way of saying or. This here means probability of A or B occurring. So let's look at our question. A 6-sided die is rolled. What is the probability that it lands on a certain number? Okay, so let's break this down again. What is the experiment? It's simply us rolling the die once. What is the sample space? What are the possibilities of our experiment? So 1, 2, 3, 4, 5, 6. These are the possibilities of our experiment. So that's our sample space. And each of these individually are our outcomes. So part A, odd, what is the probability that the number the die lands on is odd and more than 4. Well, let's name our events. Our first event, O, is odd. And our second event is more than 4, so I'm just going to name that A. This is greater than 4. So what is the probability of it landing on an odd number that is also greater than 4? Well, if we look at our sample space here, there's only one number that fits that those conditions. 5 is odd and more than 4. So number of desired outcomes, 1 over total number of outcomes, 6. So part A, it's 1 on 6. Part B, probability of the number being odd or more than 4. Okay, so odd, our or symbol, more than 4, which we've named A. So let's look over here at our sample space again. What numbers are odd? Well, 1, 3, 5 are odd. And what numbers are more than 4? 5 and 6. Since 5 we've kind of already labeled, then we're just going to label 6. So these 4 numbers are either odd or more than 4. So again, number of desired outcomes over number of total outcomes, 2 on 3. Now finally, part C, we want the probability that it lands on a number that is neither odd or more than 4. So neither odd or more than 4. Oops. Okay, so let's have a look. Which numbers are not odd and not more than 4? Well, 2 is not odd, which is even, and it's less than 4, and it's not more than 4. So that's 1. And 4 is even, and 4 is not more than 4. So that is also a case. 6 is also even, but it is more than 4, so that doesn't count. So in this case, it's going to be 2 on 6. But if we remember our definition, this event is the complement of the event we had in part B. So we could have simply done 1 minus 2 on 3, which would have given us the same answer, because 2 on 6 is also 1 on 3. And that's it for this video. Tune in next time.